Hello, hello. Today we are saying my favorite geometric word, parallelogram. Parallelogram, yes, but I like to say it, parallelogram. This is what a parallelogram looks like. All right. Um, and what constitutes a parallelogram is that it's got two congruent sides on one that across from another and another two congruent sides. The opposite, in other words, the opposite sides are congruent here and they are congruent on this way. They both are parallel. So this line is running there. You know what? I want to get another piece of paper. I'm going to flip this one over. I'm going to draw you a really good parallelogram. Okay, so these lines run parallel, and then these lines run parallel. So this is equal to this. Let's give these sides some names so we could talk about them properly. So side A and C are congruent, and D and B are congruent. Also congruent are these angles. So I'll call this angle 1, 2, 3, 4. Angle 1 and 3 will have the same measure, as will 2 and 4. Aren't those some cool facts? I think those are super cool facts, and I'm going to give myself a happy face for that parallelogram. Okay, so how can you find the area of a parallelogram? So, this is kind of a funny shaped, figure. And, we usually, when we find the area of a square or a rectangle, it's kind of easy because, remember, we're looking at how many square units something has. This parallelogram, if I was to cut it up into pieces like I could a rectangle, I'm going to have some oddly shaped, like this piece here. That's not a square unit. That's like a quadrilateral. Let's look at it. Why don't you look at it closely too? You see how that unit it's kind of off. It's not a perfect square, unlike a square, which I can do perfect, or this, is a rectangle. I can get perfect square units when I do that. So parallelograms require some special formula, okay? But you're going to see it's not that different than the formulas you've used. So let's look at our key vocabulary. Key vocabulary. We have the base of a parallelogram and the height of a parallelogram. Now, it's very, very important that you always remember how to find height. So the base of a parallelogram is basically the length of any one side. So here we're going to pick this to be our base, okay? And then the height will be from this base to it's going to be the perpendicular distance from the base to the other side. Now, we tell you this that it has to go straight up, okay? If we give you, let's say we tell you that this is 5 and this is 5, this is 7 and this is 4, okay? That 7 really is kind of a distractor. I mean, it could be used to find perimeter, but that doesn't help us find area. This does not tell us the area of the parallelogram. The height is straight up from base to base, okay? So you need to remember that. Okay, now sometimes we get these parallelograms that are really slanted, and you can't quite get, if you're drawing up the line here, like trying to go parallel, you can't do it. So sometimes what you have to do is you have to remember that the height is, you draw an invisible line here and then get your height that way. So you will see some examples where we have to do that as well. But if you simply remember the base is, the height is from base to base, or base to the opposite side, you will do fine with these problems. So I just want to give you, we're still having technical tea. Okay, here we go. So let's just look at that a lot closer. The base, which is here, it's still true. The height, this base is in this area, and it goes the height is from here to here. Okay? Just kind of think of yourself, even if you were slanted. Let's say you were leaning on a wall. Your height wouldn't change, would it? You would still be, some of you are about 4 feet something. Some of you are taller than me at 5 something. I'm not going to say. But even if you're a little bit slanted, your height does not change, okay? All right, let's do some fun problems now. So the formula to find the area of a parallelogram is easy. It's area equals base times height. So the base, as you know, is 11 here. And the height is from base to base, 7 centimeters. Oops, I don't need to write 7 centimeters. I get 11 times 7, 77 centimeters squared. And that's it. Okay. Example 2. We have 9 meters for the base and 6 meters for the height. So I'm going to go area equals base times height. Now remember, write down the formula. Write down the formula. I don't want to write down the formula. Yes, you need to write down the formula. I don't do it. This hand is more manicured than this hand, therefore it wins. Okay, thank you. All right, here we go. So the base is 9. The height is 6. 9 times 6 is, oh boy, I'm having a brain issue. Oh, someone just told me in the house, 54 degrees. No, not degrees, 54 meters squared. That is my final answer. You know what? I'm going to draw another example. I'm going to just make this example. It's not actually going to be example 3. We'll call it example 2B. I wanted to draw one of those slanted guys, just so that we have some experience with the slanted the kind of parallelogram that doesn't give us the height on the inside here. So, and I'm gonna thank you for your patience. Okay, so this parallelogram looks like it's cut. It's actually got a base of about 1, and the height is, I'm actually gonna use millimeters, 39 millimeters. Yeah, it's 39. So the height is 39 millimeters. I'm going to measure this one more time, make sure that this is about 11 millimeters. Okay, so once again, they give us the height here. Now, I know that this is the height because it tells me it's from base straight up perpendicular to base. Okay, and so area equals base times height. I already won the write down your equation argument here. The base is 11. The height is 39. I'm going to do my side work over here just to make sure I get it right. 9. Okay, my answer is 429 millimeters squared. I'm just looking at the work again to make sure that my math is correct. Yes. Okay. All right. This is a long, it took me forever to write down this word problem. Okay. A treadmill's, okay, and you know what a treadmill is. Those are the things that we run on at the gym. And so when we're on the treadmill, okay, here's a treadmill. Here's the person on the treadmill. This person looks like they're lunging on the treadmill, but okay, we're going to actually make, okay, there. So they are walking on the treadmill. So this usually is a belt that goes ying, 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 ying. Okay, so when the manufacturer makes a treadmill, usually this belt is flat and it has to be wrapped around the treadmill and connected. So this is what this problem's all about. A treadmill's belt is the shape of a parallelogram before the ends are joined to form a loop. That loop is what goes round, round, round so we can walk on it. The belt's area is 2,052 square inches. Okay, I think that's something that I need to remember. Belt's area. Okay, I am underlining that. The belt's width is the height of the parallelogram. Okay, is 18 inches. Find the length of the belt, which is the base of the parallelogram. This is very wordy, but let me just get to what I need to. It says find the length of the, okay, well, I don't know. But they give me a hint here. Find the length of the belt, which is the base of the parallelogram. That's my biggest hint. Area equals base times height. They want me to find the base. Okay, so I'm going to leave B alone. Belt's area is 2,052. All right, cool. They already told me that the area, so I'm going to put where it says A for area. I'm going to put 2052. And then they told me that the belt's width is the height of the parallelogram. So this is 18. So the height is 18. So I'm going to rewrite this. My area, which is 18b. Okay, now what do I need to do here? I need to get b by itself. So I'm going to divide both sides by 18. Side work over here. My estimation skills tells me that this probably will work out for me. I'm going to guess 4 because I know that, yep, 230, 272, woohoo, 114. The base is 114. I'm going to assume that that's 114 inches. Yay. Lots of words. I had to underline and ignore some of that information, but we got through it. Ooh, I love these. These are what I would call donut problems, which is where you need to, uh-oh, I need a cough. Hold on. Excuse me. You need to find the area of the shaded area. So but this wants us to write an expression that represents the area of the shaded region. So they don't even want us to find the area. That is easy. So now this is in the shape of a parallelogram, so I know that I'm going to need to use area equals base times height. Okay, so now let's take a peek. Now the way you do a donut problem is you take, I just call them donut problems by the way, you take the parallelogram and you pretend that this little hole isn't in there. Okay, now and then you find the area of that. Now that would be, the area of this parallelogram would be base, which is 13, times 9. All right, cool. We could do that. And then we're going to take away this little parallelogram, which is, it's getting a little blurry. You can't see it, but I'll tell you what it is. This is a 6, and the height is actually x. Confusing, but not really to us because we know how to handle this. So this is going to be, I'm going to find the area of the big guy first. So 13 times 9. Okay, 13 times 9 is going to be 117. 117. Is that true? Yes. Okay. And then I'm going to find the area of the small guy, which is, it's going to be base times height, which is 6 times x. So base is 6 times x. A equals 6x. Okay, so my answer is 6x. So really, to find the area of this yellow area, I need to take 117, which represents this whole thing, and take away 6x. Is that an expression? Yes, it is. That's as far as we can go, in fact, for now, because we don't even know what x is. So here's how, let me review how I did that. I found the area of the larger parallelogram. I also found the area of the small little parallelogram. And it's almost like I cut out a little hole, because I take out that piece, I subtract it, and then that gives me the shaded area. It's like a donut. See, here's my donut with chocolate all over it. Donut hole gets removed. Just like that. That is why it's a donut problem.